I think the best way to start this chapter is going over slope-intercept form, which is a very convenient way of writing a linear equation, where we have everything we need right in this form just to graph the line. So the way it works, what I would do right now, if you're not familiar with slope-intercept form, is pause this video and write this down in your notes. Okay, I'm just going to continue. M represents the slope and B represents the y-intercept. The y-intercept is where the line crosses the y-axis. So on this equation, right here, I'm going to look, and I see that 3 is in the position of B, which is the y-intercept, so I'm just going to plot it, the y-intercept, where the line crosses the y-axis, and I'm going to plot it right here at 3. That's where the line is going to cross the y-axis. And our slope is rise over run, as you're probably familiar with from last year. And rise over run is 2 over 1. We've got a positive slope, so we're going to be going from lower left to upper right. We're going to be going in that direction. Rise over run, that means we're going to rise 2 and run 1 on the x-axis, and we're going to draw our line. And that's not the straightest line, but it should be straight. So let's go to the next example. And we're going to try to graph this line, another linear equation. And I always choose black. I'm not sure what a psychiatrist would say about that, but black is kind of a boring color. But bear with me, I'll switch colors in a little while. It's not in slope-intercept form right now, because it's supposed to look like y is equal to mx plus b. So we just have to make one change, and we just have to subtract the 2 on both sides. Well, we can't combine negative 3x and negative 2, so we're just going to have to write it like this in slope-intercept form, negative 3x minus 2. And just to remind you, b is the y-intercept. That's where the line crosses the y-axis. So on this equation, the line is crossing at negative 2. And now we've got a negative 3 over 1. We've got a negative slope, rise over run, but instead of rise, we have a negative rise, which is in the downwards direction. So 1, 2, 3, and over 1. And here is our line. Let me try to get this a little straighter this time. There we go. There's our line. And now we have an equation which is in standard form. In standard form, we're going to look at in another video. But just to give you a quick brief intro and then how to change this to slope-intercept form, I want to show you the equation for standard form. This is the generic equation, so it's ax plus by is equal to c, where a represents a coefficient for x, b represents a coefficient for y, and c is a constant. And what's a constant? A constant is just a number. There's no variable with it. So let's look at this equation. In standard form, 3x plus 2y is equal to 8. We want to get it into slope-intercept form. In order to do that, recall that slope-intercept form is y is equal to mx plus b. So we want to solve for y, which we looked at in the literal equations unit in section 2.9. So let's solve for y. We can't really remove that 2 from the y yet. We have to subtract 3x on both sides. And we wind up with 2y is equal to negative 3x plus 8, and then we're going to divide 2 on both sides, and now we have it in slope-intercept form, plus 4. And don't forget the 2 goes here and here, so we can go ahead and divide the 8 by the 2, and we wind up getting 4. So now we have it in slope-intercept form. Remember, b is our y-intercept, so let's plot the 4 on the y-axis, because that's where the line crosses the y-axis. And we've got negative 3 over 2 as our slope, rise over run, except it's a negative slope, so we're going to go down 3 and over 2. And now we're going to connect our dots.